Hi there! Today I want to talk about tube circuits. Call them valves or tubes or vacuum tubes or whatever you want to call them. And of course I'm very interested in AM transmitter circuits. There's a problem with these tubes. Well, I do have a lot more tubes than this one, but there's a problem with these tubes, and this is the high voltage. So meanwhile you can make a transistor circuit with like a 9-volt battery or 1.2 volt battery. These tubes will require like 200 volts or 300 volts or some even more. So it's very dangerous for beginners if you work with these high voltages and want to make a tube transmitter. But there are so-called battery tubes, and this is one. Let me search the package for it. Well, I should have prepared that better. Oh, there it is. It's called 1T4, and you can look it up, and there are many similar tubes, so tubes that are having the same connections and just another type of letters written on them, but they are physically obviously the same. So with these tubes you can make a transmitter, and guess what, I made one. I will come to that in a couple of seconds. It is said that a tube is can be compared with a transistor. But I made this comparison, and it's definitely not that. Because on a transistor you have your emitter circuit and your collector and your base. And if you add a signal between emitter and base, a positive signal on base, it will get conductive between emitter and collector. But a tube is another story, a very, very different story, because you have so-called grids. Grids are compared with a transistor's base, but they are something completely different. Let me get my pen. So there it is. Usually you have three grids. Grid 1, grid 2 and grid 3. In this specific tube here, the third grid is already laid into or connected to ground internally. So usually the third grid, if you want to connect a tube, you have to know some stuff. Okay, this is like a one version video, I'm not editing it, so maybe I may sound a little bit weird or strange or whatever. Because I didn't make this before, I just make it right now because it's getting dark outside because of winter time, and I want to get it on camera before it's too dark to film it. Maybe I could turn on the light, but yeah, I want to get it on camera now. Anyway, so tubes are having three grids, and for example there's cathode, anode and a grid. The cathode would be like the emitter, the anode would be like the collector, and grid would be base. But if you just go ahead and connect cathode to ground, and for example an LED between anode and plus, and then you feed in a signal into grid, well, nothing happens. Even if you turn it on, it can be that the LED is kinda lit up a little bit or is not lit up. That's because of these grids. And if you don't know how to connect a tube, you will definitely get in serious trouble with these grids, trust me. I made many experiments, and it makes you angry. So there's my tip. If you want to experiment with tubes, you just have to know a few things to get them working like a transistor. There's this third grid, second grid and first grid. This is a so-called pentode, but if the upper grid is connected to ground, well, okay, I would have to look up how it's called then, but it's not a pentode. But anyway, usually you have three grids, and that's called a pentode. And the third grid, you can either connect it directly to anode, that will give you more power, or you can connect it to ground, that will give you more linearity. Usually on circuits, the third grid is connected to ground. So if you have your tube and want to experiment with it, the first thing that you're going to do is connect the third grid to ground. The second grid wants to see a positive voltage to be conductive. At least that's what I found out. So you can connect, for example, the second grid to a potentiometer, so you can dim the LED. The first grid needs to see a negative voltage, so you want to connect it to ground via a resistor. Do not connect the first grid to B+. It can work, but physically I was told that the first grid is very close to the cathode. And so if you connect it to B+, it can arc over internally, and eventually the tube can get destroyed. So you want to connect the last grid to ground. And also there is a rule so that the cathode needs to be more positive than the grid And so you want to connect a resistor between the cathode and ground. Could be a 10K resistor or so. If you would, for example, do this on a tube, you would get the result that you can align the brightness from the LED with a potentiometer. But hey, this is just some basic tips if you're working with tubes, because I was wasting hours experimenting with tubes and I had no clue how to connect the grids. Then I figured it out. So if you always keep in mind, third grid can be connected to anode or ground. Second grid wants to see a positive voltage, and first grid wants to get connected to ground, and you want to have a resistor between cathode and ground. So now let's talk about this transmitter. This is a Meissner oscillator transmitter, and the cool thing is that here you can see my supply. This is the heater supply, and this is the anode voltage. You may be wondering, why is there a 9-volt battery when I'm talking about anode voltage? Well, it's something special about these so-called battery tubes. They will also work with a very low voltage, in this case just from a 9-volt battery. So there are problems with these circuits. The problem is, I was also told, this tube has 1.4 volts filaments voltage. And you want to keep these 1.4 volts. If you take 1.5 volts, the tube will get destroyed because this is a directly heated tube. And if you overvolt a directly heated tube's filament, it will get destroyed. And if you undervolt it, the tube will get bad and worse and worse and worse over time. So you want to have exactly 1.4 volt. And this is not good because a AA or AAA rechargeable battery has like 1.2, 1.25 volts, which is too less. And the new battery has 1.5 volts. So one thing that you can do is you can buy one of these big mono cell batteries, use a potentiometer in series with this battery and align it to 1.4 volts. The next thing I will show you practically. So here I have my tube transmitter set up. Of course, I would request and I would like it if beginners would rebuild this tube transmitter, because therefore I made this schematic and I made this tube diagram, which is of course the wrong way around, because 7 would be there and 1 would be there. But hey, look at these numbers and you can look them up. So if you hold this tube like that, you can see which pin belongs to where and where you have to wire it on the circuit. Anyway, okay, so here's my circuit. I'll connect the heater voltage, which is, by the way, not 6 volts. It's 1.4 volts, but that's an electronic circuit that manages it. Anyway, so now the tube is on and we have a signal. Now I push play on my cassette player and I connect my cassette player to the audio input from this tube transmitter, which is of course quite dodgy with one hand. But hey, I'm making this a live video. So, it's connected. And you can hear the music from the radio, but it's very silent. Very silent. And even if I would crank up the volume to maximum on my cassette player, it would get louder, definitely would get louder, but it's by far not as loud as you want to have it. And that's one problem with these tube circuits, because as they are like a field effect transistor controlled by voltage, you will require quite some high voltage on the on the grid to get modulation. So what can you do if you just want to build a tube circuit? We already solved the problem with the 1.5 volt being too much. And now we want to solve the problem with the audio. So there I can buy one of these. This is a 1 to 10 audio transformer. So it will step up the voltage 10 times from the input to the output. So now if I connect my cassette player on the input from this 1 to 10 audio transformer, so I'm connecting it, and now I'm going ahead and connect my output from the transformer to my tube circuit, which is of course very funny to do it with one hand. So I'm connecting it. There we go. So now it's connected, and now if I push play, it's getting much louder. Now we are talking about an audio level which is quite viable and can be used in normal applications. So what you would need if you want to build a tube circuit, which is just a tube circuit, no silicium transistor, no germanium transistor, just the vintage tube and some batteries. I mean, a 9 volt battery is nothing special, and a mono battery with 1.5 volts is nothing special as well. Then you can go ahead, use one of these 1 to 10 audio transformers. Here's your MP3 player on the input, and on the output there's the tube circuit. Or for the battery you can use this circuit here with a 1.5 volt mono battery, it will last quite a while because it's drawing only like 50 milliamps of heating current, and with a potentiometer you can then align it to 1.4 volts. It is like plus minus 0.05 volts, so it's really very bad with these battery tubes, to be honest, but hey, therefore you don't need an inverter. I can run it with my 9 volt battery and it's working just fine. There's even lots of space on the potentiometer which I could still align to get it working better. So, what do you want to do now? If you don't have this transformer, you can get this tube and you want to make your own tube transmitter on medium wave, and it should be low voltage because you are afraid of being shocked. So you just want to get one of these battery tubes, which I said before is a 1T4, or if you just look it up, you will find many comparable tubes. Well, you can go ahead, like I did, and support it with some electronic circuits. You can make a hybrid transmitter. For your heater voltage, you can use this circuit. This is my 6 volt supply. It can also be 9 volts or 12 volts, going into an LM317. And on the output, it puts out 1.4 volts. This voltage divider, I looked up for a program. There is a program where I can type in values and it will calculate what is the output voltage. And I calculated it. It was 120 ohms. I'm sorry for the bad filming. It was 120 ohms for the second resistor, but I made it a little bit smaller to have some space for the tolerances of the resistor. And hey, I measured it and it's exactly 1.4 volts. So this is a circuit that converts 6 volts into the heater voltage. And so you can use two batteries. You can use a battery pack for the filament and you can use a 9 volt battery for the anode voltage. The tube is drawing only very low current, so you will get hours of running time or playing time out of it with one of these 9 volt batteries and a package of 4 AAA batteries for the filament voltage. The next thing is, since you don't have this transformer and you will be having trouble getting it, and it's kind of let's say weird, I don't like it, you can go ahead and take a just normal NPN transistor like the 2N3904, make this small circuit connected to the filament voltage as well, and then you also have your audio amplifier. I'll attempt to hook it up, which is very hard because these contacts, as you can see, I was using old alligator clips to keep them in place because this is very dodgy. Of course, if you want to build it, you want to solder the components directly to the tube, and also you want to get a so-called tube socket, which helps you to mount the components. Anyway, so now I have connected my preamplifier, where you can, by the way, take out the 47 ohm resistor and use it then there, but I'm having two 47 ohm resistors. And now if I connect my audio source to this circuit, which is once again with one hand very funny. Okay, I connected to this preamplifier, so I'm not using the transformer now. And now if I push play, oh, it's even too loud. But you can hear it's working just fine, just as it's supposed to work. So this is my complete tube transmitters, which I really recommend for beginners because once again you can run it with two batteries and it will run for hours with these batteries. Here is the schematic. Now you can go ahead and press pause on the video if you want to rebuild it and redraw the schematic. There is the 9 volt connection and there is 0 volt connection from the 9 volt battery and there is the 1.4 volts filament voltage. And with this potentiometer you can just align it for the best audio quality. For these coils, I'm using two bi-able 100 microhenry inductors, which are held parallel as they form a RF transformer, so you don't even have to wind your own coil. Here is my other help, and here is my circuitry for the electronic supporting circuit for this tube circuit. Okay, I would really like it if you rebuild it and write me a comment about that you have rebuilt it. This is a 100 microfarad capacitor. And if it doesn't oscillate, if you rebuild it, everything is right, but it doesn't work, you just swap the polarity of the coil. So you just swap the polarity where the grid is and where the ground is from the second coil, and then it will start oscillating. Okay, that was a short view about, well, let's say tube circuits from my experience. I did make another much better tube circuit, but I want to test if you rebuild these things before I make it public. And if you rebuild it, don't make it that messy, take a wooden case and make it properly. Okay, a tube transmitter for beginners.